we already trained our model and using our model to predict using our test data. And remember, we got all sorts of array of info, but that is not actual data. That is not what really happens. It's just some of the point that we think it happened. Okay, so it's like we already got that hold of say this line here, and the prediction is, for example, right here we make prediction of the red of the blue dot, but actually the real dot real data is at here. Okay, so we need to find the difference and we need to score that. Okay, so we need to have a certain matrix to find the goodness of fit. Okay, so essentially you got all sort of dots and you got this line to fit all this data. So we're going to use a matrix called R square. Okay, R square is the pretty classic score for your judgment of whether this is a good fit or bad fit. So essentially just this model explain which kind of percentage of the variability of the variable that you want to predict. Okay, and most of the time you can get 80% and 90%. That's a pretty good prediction. And maybe in real life sometimes you may just get 30% or 40%. So let's try it out. Okay, so what are we going to do is to test. We already made our prediction. Import model that can automatically find the best fit, and once we find best fit, and using that model to make prediction. Okay, and once you already made that prediction using R square to check whether our model is good or not. So we just need to test it and then have it scored, so we know that maybe just explain 90% of it or 80% of it or just 5% of it, so it's a pretty bad fit. Okay, so we're going to take out this tool from sklearn, and we got matrix inside, and we're going to import the R square score. Okay, so once we got that, we run it and successfully import it, we can use it. Okay, so the score here, accuracy. Okay, let's just using M as a matrix. Okay, so the matrix will be, and we already got the R square score. Okay, R2 score, and this will take 2 arguments. So essentially just a quick and smart way to compare the prediction that you made using your model that and the actual data. Okay, so we got this actual data here will be the Y test, because you used Y train to train that, and X train, Y train to train that, and you got the actual data here. I think it's called a Y test, right? Underscore, I think. You just input that, and it will just give you the I think it's a float number here. Okay, and of course then you can print this M out, so the matrix will be printed out. So it's 0.93, is pretty high, and that means that this model explained 93 or approximately 94% of the variability of the Y. So it's pretty good fit. So I'm going to say this model scored pretty high, and it's a pretty accurate model. So you can use it in real life and have a pretty high confidence that this model will give you the a prediction. Okay, so if it's pretty deviate from this model's prediction, there'll be pretty low possibility of that scenario will happen. So you have pretty high confidence with this model. Okay, so yeah, that's pretty much how we use this is just the first example of how we use the power of computer to train our model and to make our prediction, and we can check whether this model is good or not. Okay, we haven't got this plot yet, so I think maybe next time I'm going to share with you guys a little bit visualization so you can get a better idea of what is going on right now. Okay.